In this lesson, we're going to answer the question, how do I use dot plots to display numerical data? So first, let's talk about what is data? We've talked about it before, you've probably collected data in previous years, but what is it exactly? Well, data is basically a collection of information. So what are some examples of data? Well, data could be, numbers. It could be measurements. And who might gather this data? Who collects it? Well, basically anyone who asks a specific question or is looking for information. So who gathers data? Anybody. You could be collecting data. And what would we use this data for? Basically, to form conclusions. And here's the fun part. How can data be organized and displayed? Well, there are so many different ways that you can organize and display data. It kind of depends on the data that you've collected. It also depends on your audience. It depends on, what information you're trying to convey. So maybe we might want to use bar graphs, pictographs. I always love pictographs, they're fun. Let's see, we've got tables and line graphs. We can do, we'll get into dot plots, box and whisker plots, etc. So there's lots of different ways that we could display data. So now let's take a look in our workbook. I want you to open your workbook to page 319. We're going to talk about numerical data. And if you look at the word numerical, it probably looks a little familiar because the beginning of it almost looks like numbers, maybe? Numerical data basically involves numbers and quantities. So one example of numerical data is the number of students in your class. The answers to these questions involve numerical data. How many students are in your class? How does the number of students in your class compare to the number of students in other classes in your school or in your city or in your state? But numerical data is all about numbers, quantities. So for each group of people named below, you're going to describe a kind of numerical data that could be collected. Then decide if you would expect all of the data to be the same or if you would expect it to vary. Explain why. So when we say all the data to be the same, obviously, we expect most of the numbers to be the same. But if you expect it to vary, that means that you expect it to be different, that not every number is going to be the same. Let's see, for each student in your school, well, here's an example. Maybe I would want to know the length of time that it takes each student to travel to school in the morning. These times are going to vary because students live different distances from school. The closer you are to school, it probably will take you less time to get here. And the further you are from school, it'll probably take you more time to get here. It also might vary because of, how you travel to school. Maybe you're walking to school, maybe your mom or dad or whoever's at home brings you to school, or maybe you take the bus. So how about this one? For each student in your class, what might you want to know? What numerical data, or what type of numerical data might you collect? I don't know, I'm thinking, how about the number of sisters and brothers each student has. And this is going to vary because not all families are the same size. So I do expect different answers. Somebody might only have one brother or sister. Somebody might have 4 or 5 brothers or sisters. Every family is different. You can answer the rest of the questions on page 319 on your own, or I shouldn't say answer questions, but try to come up with situations where you could collect numerical data. Moving on to page 320. Now we're going to talk about comparing numerical data. Fitness testing sometimes involves the number of crunches that can be completed in a given length of time. And as you know, crunches are often called sit-ups. The data below shows how many crunches a group of 6th grade students from 2 classes were able to complete in 1 minute. So we have Miss Jackson's class on the left, Mr. Ryan's class on the right. So which class do you think did better in the crunches? And why is this question kind of difficult to answer? Well, it's difficult to answer because it looks like most of the numbers are the same. Most of the data is similar. Let's see. The least and greatest values are nearly the same. If you look at Miss Jackson's class, it looks like the least number of crunches was, I think, 32, and the greatest was 44. And if you look at Mr. Ryan's class, the least was 31, and the greatest was 44. So they are very, very similar. What are some different ways that you could display the 2 sets of data so the sets would be easier to compare? Let's see, I'm thinking a bar graph would probably be a double bar graph in this case. A double bar graph would be a great way to compare the 2. And then for number 8, choose one of the ways that you named in exercise 7, and why would that way make the data easier to compare. So I obviously picked a double bar graph in number 7. I think that one would be easier to compare because we could compare the heights of each bar for each class. So I love double bar graphs. All right, now moving on to page 321. Same thing. Same situation. We've got Miss Jackson's class, we got Mr. Ryan's class. We're looking at their crunch data, but this time we're not comparing them. We're actually going to put them in a dot plot. If you look down here, you have the definition of a dot plot. A dot plot displays the frequency of numerical data, and a dot plot uses dots to show how often numbers occur. So if you look at this dot plot here, we've got our number of crunches. Notice we have 1 dot above 31. Well, that must be for Jorge. Jorge had 31 crunches. We've got 2 dots above 32. That must be for Ava and for Raina, because they both had 32 crunches. Look all the way at this end. We've got 2 dots above 44. Well, that must be for Tyler, who had 44 crunches, and for Omar, who had 44 crunches. So this time we're not comparing the 2, we're compiling the data into one dot plot. The data tables show how many crunches various students completed. Is the number of students shown in the tables the same as the number of dots in the dot plot? Well, let's count them and find out. Let's see, in our dot plot we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 dots. And in our tables here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, we have 12 students. So in this case, yes, the number of dots in the dot plot is the same as the number of students in the two tables. How does the dot plot represent the data in those tables? Well, each dot represents one student. Missed an E there. And the number of crunches each one did. And last, number 11. In the dot plot, there are 3 dots above 36. Which 3 students do the dots represent? And explain how you know. Well, let's see. 36. We've got Lucas, Alexis, and Leah. So Lucas, Alexis, and Leah. Oops, that was supposed to be a semicolon. Each student did 36 crunches. That's how I know that each of those dots represents Lucas, Alexis, and Leah. So finally, the takeaways. Numerical data. Remember, numerical data is data that involves numbers and involves quantities. When we collect numerical data, we expect it to vary. We expect it to be different. Typically, you don't always get the same numbers. And then a dot plot. Well, a dot plot is a display that shows the frequency. Frequency just means how often or how much. So it shows the frequency of numerical data. A dot plot uses a number line and dots to show how often the numbers in a set of numerical data occur.